Hi, I'm Daniel Walden, and welcome to Science News. Today we will talk about the top 5 science news around the globe. Number 5. Unexpected discovery by NASA's MAVEN on Mars helps explain disruptive phenomenon on Earth. NASA's MAVEN, Mars Atmosphere and Volatile EvolutioN, spacecraft has discovered layers and rifts in the electrically charged part of the upper atmosphere, the ionosphere, of Mars. The phenomenon is very common at Earth and causes unpredictable disruptions to radio communications. However, they do not fully understand them because they form at altitudes that are very difficult to explore at Earth. The unexpected discovery by MAVEN shows that Mars is a unique laboratory to explore and better understand this highly disruptive phenomenon. Number 4. Vampire star sparks brilliant super-outburst while gorging on its neighbor. A vampire dwarf star is sucking the life force from its partner star, and their entanglement produced a rare super-outburst. NASA detailed this previously unknown dwarf nova, a brief eruption from dwarf stars, in a statement on January 24. The system brightened by a factor of 1,600 over less than a day, space agency officials said in the statement, and this uncommon sighting was made by a mission targeting an entirely different cosmic population. This rare finding was made by accident, according to the research team that found the super-outburst. The Kepler Space Telescope is now retired, but when it was scouring the sky, it searched for exoplanets that dimmed their parent stars as they moved across those stellar faces. Because it was designed to look for variations in brightness, Kepler was able to pick up on this super-outburst. Number 3. Team identifies low-energy solar particles from beyond Earth near the Sun. Using data from NASA's Parker Solar Probe (PSP), a team led by Southwest Research Institute identified low-energy particles lurking near the Sun that likely originated from solar-wind interactions well beyond Earth orbit. PSP is venturing closer to the Sun than any previous probe, carrying hardware SWRI helped develop. Scientists are probing the enigmatic features of the Sun to answer many questions, including how to protect space travelers and technology from the radiation associated with solar events. Number 2. New quantum switch turns metals into insulators. Most modern electronic devices rely on tiny, finely tuned electrical currents to process and store information. These currents dictate how fast our computers run, how regularly our pacemakers tick, and how securely our money is stored in the bank. In a study published in Nature Physics, researchers at the University of British Columbia have demonstrated an entirely new way to precisely control such electrical currents by leveraging the interaction between an electron's spin, which is the quantum magnetic field it inherently carries, and its orbital rotation around the nucleus. We have found a new way to switch the electrical conduction in materials from on to off, said lead author Berend Schwarzenberg, a PhD student at UBC's Stuart Blusson Quantum Matter Institute (SBQMI). Not only does this exciting result extend our understanding of how electrical conduction works, it will help us further explore known properties such as conductivity, magnetism and superconductivity, and discover new ones that could be important for quantum computing, data storage and energy applications. Number 1. Mystery, tracing the origins of colliding black holes. Researchers up until now have theorized the formation and existence for pairs of black holes in the universe, but the origins of their predecessors, stars, still remains a mystery, said LIGO and Vanderbilt University astrophysicist Karen Yanni and co-author Avi Loeb at Harvard University about a new study that leveraged Einstein's general theory of relativity, which tells us how black holes interact and eventually collide, using LIGO data to take an inventory of the universe's time and space resources at any given point. Yanni and Loeb developed the constraints accounting for each step in the binary black hole process, the number of available stars in the universe, the process of each star transitioning to an individual black hole, and the detection of the eventual collision of those black holes, picked up hundreds of millions of years later by LIGO as gravitational waves emitted by the impact. Since the breakthrough in gravitational wave astronomy back in 2015, scientists have been able to detect more than a dozen pairs of binary black holes by their collisions into each other due to gravity. However, scientists still debate how many of these black holes are born from stars, and how they are able to get close enough for a collision within the lifetime of our universe. Thanks for watching this video. For more videos, please subscribe to Science News. For more details, please visit widelyexplored.com.